Hi, everyone. I'm Brian McLaughlin, and today I'm going to talk about how Parasoft JTest can help you ensure that legacy code continues to work properly when changes are required. Feel free to submit questions at any time during my presentation, and I'll review and answer as many of them as I can at the end of the session. By the way, this is a second part of a two-part series. A couple of weeks ago, Grigory Trofimov did the first part. If you haven't seen that one yet, feel free to go back and watch it on Bright Talk. Grigory's focus was more on the business and management side of the conversation, whereas this session is going to be more technical. And before we get started, if the slides appear blurry to you or you have any other issues, make sure that you adjust your Bright Talk window video settings and maximize the webinar to the full screen view. Okay, so first, in our conversation, I want to define what I mean when I use the term legacy code. It's a commonly used word, but what exactly does it mean? Is it just code that's old? Well, no, that's a little too simplistic. Code can be years old and still not referred to as legacy because you might be working with it every day. So is it code that you've inherited from someone else? Well, sometimes, but not always. So the definition that I like to use and the definition that I want to use today is this one. It's the part of your application where detailed understanding of the code has been lost. So either the person who wrote it isn't in the organization anymore, or they aren't on your team anymore, or maybe they've forgotten how it works. Whatever the reason, we're going to refer to legacy code as legacy because it's existing functionality where nobody is really comfortable making changes. And don't misunderstand, we're still talking about functionality that has value. It's important to the organization. I'm not going to include dead or archived code in this definition because the whole idea here is to talk about projects where we're going to need to make some changes and that those changes are in a valuable code. So here's the issue. If you're not comfortable making changes without breaking it, you need some good tests, don't you? You need some good regression tests, probably unit tests and functional tests, right? We're all familiar with the test pyramid and how you want to have, a full suite of tests there. But how are you going to write those tests if you don't understand how the legacy project works or how it's even supposed to work? And if your current test coverage is very low, where do you even begin to increase that coverage? So the good news is a test automation tool can help us with testing that legacy code. Let's talk about how those tools can address some very specific challenges in testing legacy code. So one challenge is just the upfront time cost of generating meaningful unit tests that are isolated with mock dependencies and correct assertions. And as I said before, there's a lot of tests to generate. It can be prohibitively challenging to generate the right tests. So to address this, we can adopt an autonomous test creation tool to generate readable and complete unit tests. Second, achieving coverage goals can be a challenge. With legacy projects in particular, some of the code may get refactored or updated, but there's often a lot of code that you won't touch. Now, if we assume most of our legacy code already works, then backfilling the project with tests can take a lot of time away from the task of making changes. So we need to track not only overall code coverage metrics, but also modified code coverage so that we can focus our testing efforts where they're needed. The modified code coverage also puts us into a best practice for developers of writing tests as you go, so that you can also build up a good set of tests over time, which will expand your overall code coverage. Now, another challenge can be that once you do have that complete suite of unit tests, they can take a long time to run. So either if you're running them locally on your IDE before you're committing them, or if it's in an automated process. So in other words, the feedback we get as developers on new or changing code takes a long time to get, right? This is especially true for legacy code. We want to be very careful not to cause regressions. So the instinct would be to run all of your tests before committing, or all of your tests in a CICD process. But that can take a long time, right? Especially with a lot of functionality in a legacy project. So to address this, we need a way to intelligently choose which tests to run based on code changes. If we can know exactly what tests to run and when, we can ensure that the right behavior is validated quickly, and that's going to save us time and give us more confidence earlier in the development cycle that we're not breaking the legacy project. Now, once they're committed and running, maintaining unit tests when the code base changes again is going to take more time, right? Especially if you don't understand the legacy code that well. Or in cases where maybe the test has some tricky test constructs or complex object initializations or mocks. So we need a tool that can help us update tests quickly so we can get back to building functionality. And then finally, when tests run and then they fail, we need to be able to diagnose the root cause, right? So if that's taking a long time, especially if you're using something like a debugger, right? A debugger is a really powerful tool, but it's also really complex. And it's tricky because they don't actually show you directly how to fix the test. That requires an understanding of the code, which isn't always the case with legacy projects. So we need good visibility into the true runtime test flow with useful but not overwhelming detail and targeted help in fixing those tests. So let's start by imagining our legacy project, right? Let's say maybe it has no tests at all. The first thing we probably need to do is to generate an initial block of tests that act as a regression suite, right? To cover as much of the legacy project as we can. Now, as I mentioned before, we can use an autonomous test creation tool to accomplish that first step. And autonomous tools are great because they can analyze the code for us, they can resolve code paths and variables, and they can auto-generate pre-configured tests. But it doesn't always get us all the way to our coverage goals, right? Optimistically, sometimes we will see 50, 60% code coverage, but oftentimes our target is going to be closer to 80%. So what we're going to need long-term is a tool that'll get us the rest of the way to fully covered source code using a variety of different techniques. And I'll talk a little bit about how we get the rest of the way in a little bit. But for now, let's see how far we can get with an autonomous test creation tool like Parasoft JTest. Okay, so here's JTest. It's running as a plugin in Eclipse. And I have a legacy Java project, which, it has a bunch of code in here. There's one package here that manages a bookstore. And if you look at the tests, there's not a whole lot there. So let's start by just generating some tests as a regression suite for a couple of classes that just aren't covered yet. So let's grab a couple of classes, and I'm going to go in and create a test suite for those. And what I want to do is I want to get the maximum code coverage because I'm trying to cover as much of that as possible. So let's go ahead and run that. Now, what JTest is doing is it's going through those classes that I had selected, and it's figuring out which methods it can generate tests for. It's gonna do that test generation, and then once those are generated into those files, it's actually going to run them. It's going to run them. It's going to collect coverage data. It's going to collect runtime actual input and output values and things like that. And then it's going to generate assertions for those tests automatically. So it looks like that finished. So 16 methods total between those two classes and 27 tests. So for each of these methods, there's more test cases than there are methods, probably because there's multiple code paths. So this generated separate tests for different code paths. All right, so let's take a look at what it generated. Let's take a look at order manager tests. So what did we get? Now, if you're familiar with JUnit already, there's not going to be a whole lot of surprises here. But I do want to point out a couple of specific things. One is that, this test, and actually, like if I scroll, you'll see this is fairly common. A lot of these look like they were written by hand. So, for instance, the test is, following some naming conventions. It's named after the method under test. There's Java docs in here telling you what it's testing and who generated it. And you see things like values being set up and defined, and lists are initialized with things. There's even cases where there's a parameter passed into the object under test that's mocked, right? Because we don't necessarily want to test the behavior of book. We want to test the behavior of order manager. So it's mocking out those dependencies, and it's generating some interesting assertions, right? It grabbed the response value and it's asserting on that, and it's asserting on other aspects as well of the thing. So yeah, so pretty decent tests that are coming out. Let's go ahead and run this just to see what we're getting. Okay, so a couple of interesting things here. First, I noticed that not all of the tests are passing. This isn't really unexpected. These sorts of things do happen because sometimes the application does things that the tool doesn't anticipate. In this case, it looks like there's a null pointer exception, which is not great. So let's take a look at why. So if I look at the stack trace, it looks like my guess would be this is probably where the null pointer is. It's probably not this, because if it was, you'd probably see some other behavior. But let's take a look in a little bit more detail. So one thing I can do is, as a developer, I can try and understand where the null pointer is. But because I ran this with JTest, I actually get test flow down here as well. And there's some additional information that can give me. So if I switch to the variables view, for instance, and let's drill down into this test. This test for a null pointer exception. And if I drill down, I will see get book. So here's the call to get book that we're looking at right here. And what's happening is, oh, this is a mock. So order is a mock and get book is a call on a mock. And what's happening is that is actually returning a null value. So probably because that's not mocked. So let's go ahead and take care of that. So let's go to the recommendations tab, and let's specifically look at recommendations related to that test. So if I scroll just a little bit, JTest is telling me that this call to order.getBook is not mocked yet. And I have a quick fix here to go ahead and take care of that. So it added the mocking code, and it set this up for me. It's still going to return null, which would still cause a null pointer. So so I can decide at this point whether I want to instantiate a real book or mock it. Let's just mock it to make things a little bit easier. And let's go ahead and rerun that. Okay, so a little bit better. So it's not throwing a null pointer exception anymore. That's good. There's one more thing I probably need to do, though. It looks like it's failing due to an assertion error. It looks like it's expecting this exception, but it wasn't thrown, right? So that's what this means. So I kind of have a couple of options here. I could actually go into, let's select this, and let's look at exceptions and assertions. So I could just remove that as an expected assertion. But this was generated specifically because it was probably trying to validate this code path. So it expects order ID to be null. Let's go ahead and give it that order ID null. Now when I run it, it should pass. And it looks like it did. So we can see here that the test generation, I can do it for multiple files at a time. I can go in and I can take a look at what it generated, which is mostly configured. But then the real additional value that JTest is going to provide is that it's going to give you detailed information about calls that are made and what's being passed in and what's being returned, and then specific recommendations on how to fix the test if it fails, or how to improve or expand those tests. And there's one other thing that I wanted to show you while we're here, which is the coverage view. So as I'm running these, JTest is getting the flow tree and it's making these recommendations, but it's also populating the coverage data. And in fact, if I go to Order Manager, I can even see red-green markers in here, which is kind of nice. But if I go and I look at what the coverage looks like for Order Manager, wow, as a class overall, I'm getting 97%. That's pretty good. That's actually so much that I'm kind of surprised that it's that high. Normally, you don't get that with an automation tool. In fact, let's look at another class. Let's run the other one that I generated. And this one also has a few failing tests. So I could probably boost that a little bit, but yeah, see for Cart Manager, it's closer to 42%. It's a little bit more realistic for what you might get out of most automation tools. So yeah, so in a real world scenario, probably I'm going to want to be able to take some steps to improve that. So I'm going to go back to my slides here. Let's talk a little bit more. Oh, we already talked about that slide and that one. So I want to talk just a little bit more about the detail about what JTest does under the hood, the workflow that it goes through when it generates tests. So the first thing it's going to do is generate that model of the code to be tested. And then from that, what it's going to do is generate these things called recipes. So a recipe is essentially a code flow path and the constraints required to get there. Those recipes are then evaluated and sorted. So we will look at the expected coverage on a per recipe basis. We'll look at how complex the resulting test might be. We'll look at a number of different aspects and basically try and pick the very best ones. And then from those very best ones, what we'll do is we'll look at those constraints and we'll look at what variable values need to be in place in order to reach that particular code flow. That final set of recipes is then used to generate the executable code. And as I mentioned before, we then run those to figure out things like assertion values that we can add. But we also will actually go back and clean up certain tests that maybe, from a recipe perspective, it looked like they were going to add coverage, but maybe if they didn't, then, we can go back and clean them up and remove them. So that's how you get this optimal suite of tests that has assertions and it has everything pre-configured. Okay, so now that we've kind of seen how the autonomous test creation works, let's talk a little bit about coverage. So why do we focus on test coverage? Specifically for legacy code, we don't want to break something that was working, right? We want high coverage specifically to avoid regressions as we're making changes or refactoring things, right? So the interesting thing about legacy code is that generally legacy code is considered to be already good, right? Or already working properly. So the goal is to make sure that we retain that confidence in the quality of that legacy project as things change. And the smartest course of action there is to start with capturing existing behavior as a suite of regression tests, right? But once we've done that, we also need to, for our future testing efforts, we want to focus on a policy of getting high modified code coverage. Now, we at Parasoft generally recommend tracking and focusing on per sprint modified code coverage, especially if you're an agile team. This is going to allow teams to be more efficient in creating the right tests at the right time, while giving us that confidence that the quality of our application isn't degrading. A common and I think realistic target for modified code coverage is usually around 80% or so. But of course, it's up to your team to decide what they want their goal to be. Okay, remember this slide? So we saw how we took uncovered source code and we got mostly covered source code, right? One was 97%, one was 42%, which I don't know if is mostly covered, but it's at least partially covered. So now what we need to do is we need to take the next step, right? We need to be able to fill in the gaps of coverage. And there's a couple of ways that we can do this. I mean, we could do that manually, but here we are talking about JTest, so let's talk about how it can help us. So one thing that it can do is it can actually clone existing tests, and in some cases, it can even auto configure those tests for us. So it can clone and then mutate those tests for us. It also provides some specific tools to generate new tests in a very targeted way, right? So if we identify specific gaps in code coverage that we know need to be covered, we can generate tests specifically for those particular spots. And then, of course, as we saw before, there's other things, right? There's the flow tree that we were looking at. There's the recommendations, which recommendations can sometimes do a clone and mutate, but they can also just help us to fully configure existing tests. They can help us configure tests if we have to do a little bit of manual work. So having those extra tools allows us to take this path of assisted test creation, right? So it's not necessarily fully autonomous, it's sort of partially autonomous, letting us get the rest of the way. And one thing I also want to mention too, this assisted test creation flow is valuable whether you're working on a legacy project or not, right? We actually use this internally for a lot of our projects as well, to just focus on changes that we're making, even though we're not working on legacy projects. So let's go ahead and switch to JTest to see a few of these things in action. So let me go ahead and clean up here a little bit of what I was doing. So the first thing that we might want to do is we might want to take a test that kind of gives us partial coverage and expand that, right? And see what kind of additional coverage we can get. Well, one way to do this is to actually just reuse the same bulk creation tool that we were using before. So here we see cart surface test, right? So this is testing cart surface. And it already has a few tests in it. This is some stuff that was already here before we started, but it also has a number of tests that are just kind of useless. So let's say let's actually remove these because those are totally useless. And let's see what kind of coverage we can get with what's already here. Let's just see what our baseline coverage is. I get that to populate. Okay, there we go. Oh my gosh, 30%. That's not very good. I'm sure we can do better. All right, let's go to cart service and let's do the same thing we did before. Now I'm just going to leave everything selected in here, even though there's already tests for some of these methods, because what JTest is going to do, it's going to include these tests in its analysis. So it's not going to add new tests that are basically just duplicates. It's just going to try and expand the coverage as much as it can. So let's go ahead and run that. It's going to do the same thing it did before, adding tests, and you can actually see it adding things. So yeah, so it added a number of tests here. It's running them right now so that it can add some assertions. And actually it just updated. So it created 11 new tests for me. And if I scroll through here and look at some of them, yeah, see, it even added a bunch of assertions, right? So kind of the same thing as before, but this is a quick and easy way to sort of boost coverage. If you have existing tests that were, manually generated or something like that. So let's run that and see where we got from 30%. Yeah, see, now it jumped up to almost 70%. So that's not too bad for a single click to auto-generate. Not all of them passed, so probably I could go in here and do the same thing I did before and look at why certain things didn't work. But one thing that I want to do that I also want to show you is if I expand this coverage and I look on a per method basis, I see situations like remove expired orders and books, right? So if I look at this, there's like entire blocks that aren't even covered in here. So this can happen whether it's an automated test that was generated or whether it's manually generated or whatever. So if I wanted to go in and maybe manually add something, one thing I can do is take a look at the test. So yeah, this is pretty simple. And maybe what it's testing is interesting. So maybe I just want to make a new one based on it and maybe expand that. So I have a nice little action here to clone. And maybe I can go in here and do something like add a book to the inventory. Right, so I can do things like that. Maybe I want that to be a mock. To sort of configure the object under test so that this method can do its job a little bit better. Right, so maybe I do that and add an item to the cart. And the reason why I'm doing these specific things, by the way, is because the method under test here is trying to remove expired orders and books. So I'm adding a book to the inventory and I'm adding an item to the cart so that this guy, when it iterates through things, it has something to iterate through. So this is the sort of manual editing that you can do. But you can see that, for things like, I don't know what this needs to be, or maybe I want to mock it and I want specific methods to be mocked. Maybe I want to make sure that book.getID is mocked so I can do things like that. And when I run it, then I can boost my coverage just a little bit. So I think before it was at 40 some odd percent, and now it's closer to 87%. And then there's also cases too where I might see a method that didn't get a test at all, right? It actually looks like there's no get item by ID. So if for whatever reason this got skipped over by the tool, I can go in here and I have actions to individually create tests for specific things, right? So I could create a test specifically for get item ID and then maybe uncomment my assertion and things like that. So I have a bunch of those sorts of tools to add tests to increase that coverage, and then do some manual configuration there as well. And then there's another workflow that we can also use to expand that coverage that I kind of want to show you. And it actually has to do with once we are all done with this generation process and we feel pretty good about our code coverage over here. The next thing that you usually do is you commit these tests, right, to some source control, and you have them running in some sort of a nightly job, maybe a CICD job, maybe an overnight job. And maybe they're being run with, Maven or Gradle or something like that. So one of the things that comes with JTest is actually these plugins that you can use in Maven or a Gradle build, where the JUnit will actually be run using JTest. And the reason why that's particularly helpful is because that allows the JTest tool to report JUnit results and coverage data to our DTP tool. So DTP is our system that collects a lot of this data and then also integrates back to the developer's IDE. So for instance, if I were to check these tests in, and then have them run in that process and report to DTP. I can go to DTP, and this is what DTP looks like, by the way. It's basically a dashboard with a bunch of widgets on it. And I can see some of the results of some of these tests that I've generated. So I think most of the ones that have an orange bar are the ones we're interested in today. So you can see things like I've got overall project coverage. I have my modified code coverage for the sprint. I have coverage trends and test pass-fail trends. In fact, it looks like we've got a lot more failures the last 2 days than previously. And other widgets too, where I can focus on tests that used to be passing and now they're failing. Looks like there's a couple of these, so I can drill down into these and look at these test failures. I can see source code for the test itself, and I can see things like the test history. So for instance, if the test was passing for a while and then started failing, I can go back and look at what commits were made on that day, things like that. I can also, actually, I was going to show you one more thing with that tab. I can also do things like I can assign those test failures to specific people, or I can come in here and directly create a JIRA issue for it if I think it's a regression. And I can, set that all up. So there's a fair bit of functionality in there, right? Set the priority and things like that. But the other thing that I wanted to show you in DTP it has to do with the modified code coverage, right? So here I have modified code coverage, which is about 70%. It's a little bit low. Usually, like I said, I like seeing about 80%. So if I want to do something about that, I can click on it. And let's pick something. Let's look at util. So here's a file where, and you can see I've got some red-green markers here in the source code. So I can see that the green ones are lines that changed recently, and the red ones are also lines that changed, but they're not covered by a test. So the green ones are covered by a test, but the red ones are not. So that's not a great situation. So probably what I want to do is on a daily basis, I can go in here and review that modified code coverage. I can identify pieces of code that have changed and aren't being tested. And now what I can do is I can go back into JTest and actually add tests specifically for that. So let's look at util. And what was the, it is logged in. Oh, okay, here we are. So yeah, so I think these are the lines right here. Oops, I'm gonna pop up. I think these are the lines right here that aren't being covered, right? 41 and so on. So one thing I can do in JTest is I can now go in here and I can say, okay, I want to add a test that gets to here so that I can cover, these 3 lines. Maybe I need another test again that covers this, but for now, let's go ahead and generate one for here. So I can select this line and use this action down here that'll generate a test case specifically to cover line 48. So that adds a test to my util test. And it even gives me some sort of detailed information about what the conditions are that would need to be satisfied. So most of the time, the tool can figure them out with specific values, right? Every once in a while it can't, so that's why it gives you this detailed information. But let's just see what it did out of the box. So if I just run this locally, I should be able to watch the coverage here and see if it turns green. Because if it does, then that means that this test I've generated locally is covering those lines. Oh, and it does. So now I can commit this this test as is, which is passing, to source control. And tomorrow, not only my modified code coverage, but also my overall code coverage will get a little bit better. So that's a nice little workflow. Okay, let's go back to our slides here. Okay, so now that we've talked quite a bit about test generation and covering specific lines and all of that. And we talked a little bit about, committing our tests and running them in, CICD job or a nightly job. I want to talk a little bit about another aspect of this, specifically for legacy projects, where I want to ask the question, when do I want to run tests? So let's suppose that I've just made some local changes to that project, and I haven't committed those changes yet, right? So what are my options for when those tests are going to get run? So the first time, the first opportunity that I have to run those tests is in my local IDE, right, before I commit changes. Now, ideally, I would run all my unit tests, right? But that would require them to run pretty fast. So if they take like an hour to run, I'm probably not going to do that. In fact, some people say that from a guideline perspective, if you want to be able to do that, then unit tests are supposed to run within like 1 second a piece, and the whole suite has to run within a minute. And if they don't run within this amount of time, then we would need an optimized set of tests. So some people refer to that as, a commit suite, right? The problem with a traditional commit suite is that it probably isn't going to handle the specific cases related to my specific code changes. And it's also, frankly, not that likely to detect regressions in seemingly unrelated code. So the next opportunity that I have to run tests is in my CI, my continuous integration build. Now, that could run all the unit tests as well, but once again, that's probably going to take a really long time. So most people say, that should run a subset of tests. It should be fairly fast, 10 to 20 minutes. But it's not unheard of that can take hours and hours. The subset of tests running on the CI job would need to be very carefully chosen. And it often just doesn't fit into there. In fact, as an example, here at Parasoft, we had a project where we tried to do that. We took a lot of the very long running stuff and we separated it out into a separate job. And we still had a 5-hour CI test run in addition to the nightly test run. So, you could make the argument that if you just prune that commit suite, or you prune that CI job down to, then you can accomplish this. But honestly, it just doesn't scale forever. So to ensure that all of your tests get run and actually detect all possible regressions, you actually need to separate the CICD and the full nightly test run. But let me ask you a question. If I were to make a code change that caused a regression, and I commit that code change, at what point does this workflow show that regression? When does the failure show up? Now, even if we run a commit suite and it passes, and the CICD job ran and everything passes, we might not see that test failure because the commit suite and the CI job aren't running everything. We might not see that test failure until the nightly test run. Right? Not until here, not until tomorrow. So that's not actually very good behavior. And I think that we can do better. So the solution here is to use what we call smart test execution, or change-based testing. In other words, we need to intelligently select which tests to run based on a knowledge of which tests cover the specific changes that have been made to the code. And we call that process test impact analysis. So first, we gather coverage data for the tests that have already been executed, right? We saw earlier how we can collect coverage in the IDE or in a nightly job, right? Either a CI/CD job or a nightly job, and then publish that information to DTP. So the next step is then to analyze the code changes between builds and correlate those changes with the tests that cover that changed code. Now, in your IDE, we can actually use local changes to perform that analysis before you commit the code. And then in a build, if you're using one of our Parasoft plugins, and it integrates with source control, we can then perform the analysis on a CICD job as well. And once we have all that information, we can intelligently select which specific unit tests to run to validate changes to the code base. So what we have, in effect, is a smart commit suite, which runs faster than the entire suite. So we get that time savings of having a traditional commit suite, but we also know that the specific tests we run will fully cover the specific changes we've made. And we can run that smart commit suite either before we commit, right? Or we can run it in the CI job. So let's see what this looks like, both in the IDE and in our CI/CD run. So I want to show how JTest can help me find and run the specific tests for my smart commit suite. So it needs coverage information for the whole thing. Now, I do have a fair bit of coverage information in here. And what that means is that just from the changes that I've already made, if I go and I look at this impacted unit tests view, I will see that there are already some tests that it knows that I need to run before I make my commit. Now, these are actually the specific tests that I generated earlier, or that I modified, right? I added some tests to util test, and I generated some of these. And I think cart service test is one where I did the coverage up. So, obviously these are going to be there. But let's do something a little bit more. Let's go out and find, you know what? This is a file I was playing with earlier. Let's look at JDBC customer DAO. This is an interesting class. So there's a method in here that tries to create a customer object. And what it does is it adds it to the database, actually. You can see some SQL in here. So let's say that I want to change the behavior of this method. Let's do something simple. Let's ID equals customer.DAO. Let's take a look at the customer and see if it already has an ID before we generate a new one. I think this call just generates a new one. So if customer.ID is greater than 0, let's warn the user that that's already set, right? And that that's not really the way it's supposed to be, because we want to be able to auto-generate it whenever we can. So customer.ID is already set. But if it's not already set, let's do this. Actually, that. Okay, so if the ID is already set, we warn the user. Otherwise, we create a new ID, we set it, and then we continue on adding it to the database. And of course, this method returns the ID that was used. So if the customer ID was already set, it gives you back that customer ID, but otherwise it gives you the new one. Okay, now I haven't actually saved these changes yet. And one of the reasons why is because I want to show you what happens as I hit the save button. So over here in impacted unit tests, this is going to update as I save. It's going to show me what tests are going to be affected by that change. So I'm going to hit save, and look at that. So now I've got a whole bunch of tests, actually, more than I expected. So, this one was there before, but look at this. There's a whole bunch of tests in web controller. That's interesting. Now, obviously, JDBC customer DAO, I would expect to have to rerun this, right? So without impacted tests, I probably would have gone to JDBC customer DAO test and rerun it, right? Just to make sure that I didn't cause anything to break. And if I watch the coverage, it'll show me what my existing tests are covering. There's actually a code path here that isn't covered. So let's, oh, I've got a nice little recommendation here. Let's go ahead and clone the test. It actually detected that this is not, that this is an uncovered block. If I hit go to on this, it shows me. So let's make a copy, making a copy of an existing test. That's going to be create customer. And for this one, let's preset the customer that's being passed in. Let's preset its ID. Something. And let's run everybody. So that should give me coverage of that line. Oh, yeah, I got an assertion failure. Let's see, let's go to it. Expected 12434. Oh, yeah, it returns the ID, remember? So it needs to be 42. So let's update that assertion. And let's rerun it. So, even without impacted unit tests, it would be obvious that I need to rerun this test and, add some new stuff and make sure that I'm not causing any regressions. But at this point, because everything's passing, I might say, okay, I'm good. I'm ready to commit. I'm ready to commit that change. But am I? Am I absolutely sure? What about all these other tests? I wouldn't necessarily know about these other tests if I didn't have impacted unit tests. But since I do have them, let's run everything. And let's see if anything else is broken. Now, I kind of expect some of these other ones that I was playing with earlier. We already know that there were some failures that I didn't address. But let's look. Oh, look at this. Register customer controller test. This test actually failed. And if I look at the test, it looks to me like it's trying to build a customer form. And then it's using this form to run an integration test where it's trying to create a customer. So this is a JUnit that needs to get updated, right? It needs to be updated probably because in this customer form, it's setting the ID of the customer. So it's presetting that ID of that customer. Remember, I changed the behavior when you do that. So this test would need to get updated. If I didn't do this, then I would have had to catch this probably in the nightly run. But because I caught it before I committed anything, I'm able to update the test and then move on. So I think that's a particularly powerful functionality that I can use to identify and fix issues like that before making that commit. Okay, so now that we've seen how test impact analysis works to create that smart commit suite, let's see what happens when you do the same thing in a CICD test run. So remember that I said we have the Maven and the Gradle plugins to run tests and report to DTP. That plugin is also what's doing test impact analysis on your CI/CD job. So you integrate that with your source control, and what happens is that your CI/CD job now only runs the impacted unit tests. The graphs that we're looking at are actually a case study from one of the projects that we were doing internally. And the left-hand graph is before we applied test impact analysis in our CI job, and the right-hand graph is after. So I think each one of these is probably for a single sprint. You can see on the left, there's like 4,000 or 4,500 tests that were being run every single time. But on the right-hand side, you can see that count is much, much lower. It varies a lot because this is based on what code changed. But you can see that the number of tests being executed each time is much, much smaller. I think the average is like 50 or 55, something like that. So obviously, it's going to be running much, much faster. And because it's running tests specifically for those code changes, we know that it's actually validating the actual code changes. So yeah, that's much more efficient that way. And it gives you much faster feedback on your code changes. So just to summarize test impact analysis, it's used to detect potential issues as the code itself actually changes, and detects that before you commit those changes. So it's going to save you time in waiting for feedback. And of course, because you get faster feedback, from your test suite, essentially what tests you're running is going to go a lot faster. So it's going to save you a fair bit of time there as well. And we also can get visibility into, and then can therefore reduce the risk associated with making code changes, right? So in an interactive way, as I'm saving changes to my code, I can see which tests are going to be affected by that change. And so I can see how much of the application is going to need to get retested. So in addition to that stuff, JTest does also do a lot more, right? Whether you're creating unit tests, whether you're augmenting and reusing them or optimizing them, JTest is offering capabilities to enhance each of those workflows. For instance, some of our customers have found that using Unit Test Assistant, that was a lot of the functionality I was looking at before, it helps their developers actually learn more about JUnit and Mockito simply by building new tests that expanded their knowledge of things like parameterized tests or JUnit 5, or the ability to mock static methods. And when you're working with legacy projects, it's clear, I think, that we need a tool that does more than just autonomous test creation, right? We need a tool that gets us the rest of the way to our coverage goals and assists us in maintaining that legacy project and the tests into the future. So we've seen how JTest simplifies the creation and maintenance of unit tests and enables developers to quickly and thoroughly test legacy code. As I mentioned, our customers have found it reduces the amount of time that they spend building tests for all kinds of projects, especially legacy projects. It reduces the learning curve for less experienced developers and testers, and it scales across the team. So when you add all this together, we have customers that have reported that the amount of time that they spent on their unit tests gets cut in half. And additionally, JTest also performs other functions like static analysis. So it'll help you prevent defects in your production code, comply with security standards, standardize code across multiple teams. And then one other sort of last thing that I want to mention. So the demo that I've been doing today has been primarily as a plugin in Eclipse. It also ships as a plugin for IntelliJ. So if that's your IDE of preference, then we do support that as well. And there's a bunch of other libraries that we work with and that UTA has knowledge of. Obviously JUnit and Mockito, but also things like Spring, and lots of others. I think Apache Commons and stuff like that. So we detect those sorts of libraries on the class path, and we try and use functionality from those libraries in building tests for your project. All right, well, thank you for watching today's webinar. If you want to learn more about Parasoft JTest and our other automated testing solutions, please do visit our website at www.parasoft.com. And if you want to learn more about unit testing, please download our helpful ebook or request a personalized demo of Parasoft JTest. And at this time, I'll go ahead and take a few questions. So if you have any that you've been holding on to, go ahead and put them in the BrightTalk window, and we'll take a look. Oh, sorry about that. I had to click a button. Okay, so let's see what we've got from the questions, from our questions list. Okay, so here's one. Can I automatically do the test generation on my entire project? So yeah, absolutely, test creation can be done on the entire project. I know while I was doing my demo, I was sort of picking and choosing individual classes because I didn't want to do it on the whole project because that can take a few minutes. But yeah, you can do that at the project level. You can do that at the package level. You can select individual classes like I did. You can actually even go on an individual method level, and you can get that same functionality and behavior, which does all the auto configuration for you on a per method level. So there's a lot of flexibility there. Let me see, what else do we have for questions? So a common question that we get is, can we configure how JTest sets up complex objects or chooses what to mock or things like that. How configurable is that? So by default, JTest will mock most objects because what it's trying to do is it's trying to isolate the specific method under test, the specific code under test, and those other objects like things like parameters that get passed into the method under test will get mocked. Um, Objects which need to be given to the object under test when it's constructed, things like that will get mocked because we're trying to isolate that stuff. And there are a few exceptions. I think file objects, you don't want to mock. Collections objects don't actually make a lot of sense to mock. So we avoid mocking those. We tend to instantiate those. But you can also do a thing where you can actually define factory methods for very specific types. So for instance, if I have, some interface defined somewhere and for the purposes of testing, I want to use a mock that's configured in a very specific way anytime that particular type is accessed. I can create a factory method and then I can configure JTest to use that factory method when it's doing things like bulk creation. And then what it'll do is, like I said, it'll use those factory methods automatically whenever it encounters those types. So they can build mocks, or they could instantiate real objects and pre-configure them if you want. So that's a bit of pre-configuration that you can do. And then you can also configure JTest with a bit of a knowledge on things like static methods or constructors for specific types, where you might say, yeah, anytime a particular method is being invoked, specifically static and constructors, I don't want to create those objects in a test. And so you can sort of pre-configure it and tell it, always mock this static method or always mock that constructor. And so you can configure it that way. Okay, yeah, I know we're a little bit short on time. Whoops. So one of the things that I wanted to do is mention that we also have some additional upcoming content. If you are interested in hearing about how other Parasoft customers have been solving their software quality challenges, there's a QR code on your screen to register for Parasoft's automated software testing and quality summit. That's going to be coming up on November 3rd, so I encourage you to also take a look at that. I think we have time for one more question. Okay, so here's a good one. Can JTest UTA help me with integration testing? Yeah, that's a really interesting question. We hear a lot of developers who are looking to do a better job testing the middle tiers of their application, and they're looking to frameworks like JUnit to help them out with that. Now, technically, you could, and UTA will help with that. But depending on what those middle tiers look like, we also have other products which I want to mention, which actually focus on other application layers. So, for instance, if you're working on a Spring application and you want to do integration tests for some sort of like a web API or something like that, a tool like Parasoft SOA Test is actually designed specifically for testing those sorts of layers. Because what it does is it focuses on that web services layer of the application. And SOA Test has a number of benefits over other tools. For instance, you don't have to give up code coverage for your black box functional tests, because what you get is, so JTest has a coverage agent that you can attach to a running application. And then what that agent does is it collects coverage and it collects runtime data in the same way as if you were running a JUnit. So if you attach that to, say, a running Spring application, and then you run a SOA test suite to test that web layer, that agent will collect and report coverage data in the same way as if you were running a JUnit. And you can get access to that data from SOA Test. You can get access to that data through DTP or whatever other kind of reporting system you want. So like I said, there's a variety of other tools that are designed for testing some of these other layers. So, okay, looks like we are pretty much out of time. So thank you everyone for attending. It's much appreciated, and we'll see you on the next one.